Hello InfoPerson, this is Anton, and today we're going to be discussing a fascinating detective story unfolding in the satellite galaxy of the Milky Way, the Large Magellanic Cloud. And in this case, it involves a mysterious flicker of light that suddenly surprised and excited a lot of astronomers because it potentially offered us at least one solution to the mystery of dark matter. But this recent reanalysis we're going to be discussing right now potentially disproves most of this and basically explains everything in an entirely different way. A way that does not involve dark matter or anything else mysterious, but instead involves just a really strange star. And so in this video, let's discuss the relatively recent discovery of Phoebe, the event that we actually discussed not so long ago in a video in the description, and discuss this new explanation that actually does make just a little bit more sense. But first, so what exactly happened here, and why was this so exciting? And well, the original data is from approximately 6 years ago. On December 18, 2019, astronomers using the Dark Energy Camera, also known as DCAM, collected data from this very distant object that was kind of ignored and not analyzed until relatively recently. Here, a single faint star in the Large Magellanic Cloud essentially did something like this. It got a little bit brighter for approximately 1 hour before returning to its original state. And since it did not resemble a supernova or a classical nova, or even a typical solar flare, researchers wanted to find out what exactly produced this because they suspected that it was basically a gravitational lens. With a team of researchers from Swinburne University, led by René Key, eventually analyzing this event and giving it a nickname Phoebe, which they essentially explained as a gravitational microlensing event involving some kind of a relatively small object because the event was so quick. And here, because the gravity itself was acting as a lens, and because the gravity was bending the light rays, producing the magnification, in the study they were able to work out its true mass. And that's of course where things got a little bit intriguing and somewhat mysterious. Because of the short duration of the event, which basically only lasted for 60 minutes, the mass of this object had to be relatively small. As a matter of fact, this was one of the faintest such signals ever detected. And so based on the time frame, they calculated that whatever was creating this lens and passed between the distant star and us was only maybe about 3 lunar masses in total, which would make this one of the smallest such objects ever found. With this team then exploring 3 main possibilities for what this object could be. For example, it could be some kind of a really tiny rogue planet, possibly a planet in our own galaxy, or maybe even the first ever discovered exoplanet in the Large Magellanic Cloud. But here, statistically, it did not really make as much sense as something entirely different. Because a much more exciting explanation that also makes just a little bit more sense in terms of probabilities was that this was a lot more likely to be a primordial black hole. As a matter of fact, 100,000 times more likely than a planet. And these types of primordial black holes of planetary or lunar masses were also predicted by Stephen Hawking back in 1970s. And he actually used them to explain what we refer to as dark matter. He basically said that it could be a bunch of really tiny black holes, possibly only this small in size, with the mass of a moon or so, that could be creating these extra gravitational effects all over the universe. And so unlike typical black holes forming from massive stars collapsing, these types of black holes would have formed in the first few moments following the Big Bang from a direct collapse of a lot of different gas in different regions. And so in some sense, if confirmed, this would have been the first such detection, and it would have also solved a lot of major mysteries. But sometimes the easiest and the most beautiful explanations are not really the best. And so even though trillions of these tiny black holes could potentially explain the presence of dark matter, and could explain what's observed here, we still needed to have more evidence that this is indeed a black hole. And that's of course kind of difficult to achieve because if Phoebe were a black hole, it would only be 6 millimeters across, which means that detecting something very similar would be extremely challenging. But this is where this new reanalysis comes in and essentially explains things with a slightly more grounded approach, and unfortunately also makes just a little bit more sense. And so here in this recent study from the Astronomical Observatory in Poland, a team of scientists tried to independently verify some of these propositions and unfortunately did not agree with most of them. And here this team is actually really important because they technically have the longest running and one of the most important projects when it comes to gravitational lenses. They're part of what's known as OGLE, Optical Gravitational Lensing Experiment, that's been doing these observations for several decades. And so here are these Polish scientists, whose names I'm about to butcher because Polish names. Here we have Andrzej Udalski and Przemek Mroz. My apologies for butchering your names. Reanalyzed all of this data by using their own observations because OGLE has also been monitoring the same region for many decades. And they actually know quite a lot about these observations because they're basically leading the project. And so these two scientists realized that if dark matter was truly made out of these lunar mass black holes, we should have actually seen hundreds or even thousands of similar flickers in the data coming from OGLE as well. And while a few years back, we've actually discussed very similar observations by the Japanese team that tried to observe the Andromeda galaxy with the assumption that they're going to find very similar flickers all over the place. But they didn't. Out of thousands expected, they only found like one. And something very similar was found again. When the data was reanalyzed, and when extra observations were also added from the dark energy camera, they found no extra gravitational lenses, but they potentially found the smoking gun. Or basically they found the object that the initial team was looking at in their initial data analysis. And well, it turns out that this particular object, Phoebe, brightened at least 3 separate times over several years. As in, it didn't just change in brightness in 2019, it seemed to have done something very similar 2 separate times. And importantly, this wasn't actually shown as a typical gravitational lensing type of brightening, which normally involves something like this and creates a symmetrical curve, but instead resembled something a little bit more chaotic. And on top of this, based on decades and decades of observations, scientists know that gravitational lensing events are actually exceptionally rare. A gravitational microlensing event is a kind of a one-time occurrence that potentially happens once every million years for each individual object. And so in this case, a black hole or a planet drifting through space is not actually going to circle back and lens the exact same star weeks or months later. Yet in this case, Phoebe brightened several times in just a few years, suggesting that this is not a lens at all. Or basically this is not a gravitational lens, not a black hole, not even a planet passing in front of a distant object. So what is it then? Well, it's something way more common and something that we've seen many times everywhere. Here the evidence now strongly suggests that Phoebe is just an ordinary variable star. A star that might be doing something like this. It's your basic twinkle twinkle little star. It's a star that changes in brightness with potentially somewhat regular periods, and very likely due to a lot of internal physical processes, with the team from Poland pointing out that this is a common trap in astronomy, especially when you only have a few days of data. And that's because, apparently, a natural flicker of a star can easily resemble an extremely rare 1-hour microlensing effect, because they do last for approximately 1 hour, and the star in this case brightens and dims at around the same time, essentially producing a curve that does resemble a microlensing effect. And so their study is now nicknamed Phoebe, a mirage of a primordial black hole. And so this is most likely the correct explanation, and unfortunately moves us a few steps back when it comes to explaining dark matter, or when it comes to trying to find primordial black holes somewhere out there. But of course it doesn't mean that they don't exist. They might still be hiding all over the place, but might be also very difficult to find and very difficult to see. And in case you're wondering why any of this matters, and especially why this particular study matters, this is once again a really important reminder of the fact that this is exactly how science usually works. Someone proposes a bold idea, and then we try to test this against more data and other explanations that might make more sense, with the truth eventually coming out and becoming a fact. And so here the story of Phoebe teaches us at least 2 important things. First, it tells us that the long-term monitoring is actually extremely important. Or basically, to tell the difference between a passing black hole and a flickering star, we need months or even years of observations, and just having 5 nights of observations is unfortunately not enough. Second, it also tells us how extremely sensitive our telescopes are now, because even though Phoebe is a variable star, the fact that we can detect such 1-hour changes in a star 160,000 light-years away from us is absolutely mind-blowing. Once again, this star is in a different galaxy, and we're able to see minute changes from super far away. Which means that with the new telescopes that are going to become operational very soon, such as the Vera Rubin Observatory and Nancy Grace Roman Telescope, we're going to be seeing so much more because they are going to be monitoring millions of stars at the same time, likely discovering thousands of micro-lensing effects in mere months, which might allow us to finally determine if primordial black holes are real, or if we need to basically rewrite this hypothesis and explain dark matter in some other way. And so until then, Phoebe remains as a kind of a reminder that the universe is still full of mysteries, but also things that, even though might appear mysterious, turn out to be something a lot more casual. Which means that once there's some updates, we'll discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.